Dear students, I am Shawkat Ahmad, teacher, हायर सेकेंडरी स्कूल यूनसू। आज का क्लास है 12th, सब्जेक्ट मैथमेटिक्स, टॉपिक है कंपोनेंट्स ऑफ वेक्टर। पिछले लेक्चर में हमने वेक्टर की डेफिनेशन और इसके टाइप्स पढ़े। आज हम थोड़ा आगे बढ़ेंगे कंपोनेंट्स ऑफ वेक्टर। हम यहाँ एक एक्सिस लेंगे, एक्स एक्सिस, वाई एक्सिस और जेड एक्सिस। ऐसे this origin O, X, Y, Z, X axis, Y axis and Z axis. These are three mutually perpendicular to each other. Take 3 points A 1 0 0, यहाँ पे B 0 1 0, C 0 0 1। इसका मतलब यह है कि A जो है, B and C, they are just 1 unit away from the origin. They are just 1 unit away from the origin. Or I can say magnitude of OA vector. Magnitude of OA vector will be equal to 1, as is evident from its coordinates. Magnitude of OB vector is equal to 1. Magnitude of OC vector is equal to 1. Means OA, OB and OC, they are unit vectors along the three axes OX, OY and OZ. We represent these unit vectors as I, J and K. I कैप का माने है ये यूनिट वेक्टर्स। I, J and K means I, J and K, they are the unit vectors and they are mutually perpendicular to each other. We represent these vectors along OX, OY and OZ. Let P, X, Y, Z, X, Y, Z अगर कोई पॉइंट होगा यहाँ पे, so with respect to origin, we can write it as P is equal to Xi plus Yj plus Zk. Xi plus Yj plus Zk. This is called the component form of the vector. This is called the component form of this vector. P is a point, and with respect to origin, with respect to these, we can write it as P is equal to Xi plus Yj plus Zk. This is called the component form. Here Z are called the scalar components. X, Y, Z. These are called the scalar components of a vector. And Xi along with I, Yj and Zk, these are called the vector components of a vector. Vector components of a vector. और एक बात, magnitude of this vector, say R, magnitude of this vector is equal to square root of I का कोएफिशिएंट है x square, y square plus z square. This is the magnitude of the vector. Whenever we have to find the magnitude of the vector, this is the formula by which you can find the length or the magnitude of a vector. Two vectors are said to be equal when their corresponding components are equal. Two vectors are said to be equal when their corresponding components are equal. When their corresponding components are equal. For example, अगर हम लेंगे एक वेक्टर, हम लेंगे ए वेक्टर, हम लेंगे ऐसे 2i plus xj माइनस k। दूसरा वेक्टर हम लेंगे b वेक्टर इज इक्वल हम लेंगे आर आई प्लस 7j माइनस एस के। Two vectors are equal if and only if a vector is equal to b vector. These two vectors are equal if and only if their components are equal. Means 2 is equal to r. यहाँ पर r है i का कोएफिशिएंट, यहाँ पर 2 है i का कोएफिशिएंट. r should be equal to 2, 7 should be equal to x, and minus 1 k का कोएफिशिएंट है, minus s should be equal to minus 1, means s will be equal to 1. ये इसकी टाइप two vectors are said to be equal when their corresponding components are equal. This is the example. दो वेक्टर तब इक्वल बराबर होते हैं जब इनके जो कॉरस्पॉन्डिंग कंपोनेंट्स हैं ये बराबर होने चाहिए. We will take now another two vectors. Say a is equal to 2i plus j. b वेक्टर हम लेंगे i plus 2j. These two vectors are not equal. Clearly, these two vectors are not equal because their corresponding components are not equal. Here, I का कोएफिशिएंट है 2, यहाँ I का कोएफिशिएंट है 1, 2 is not equal to 1. यहाँ पे J का कोएफिशिएंट है 1, J का कोएफिशिएंट है 2, 2 is not equal to 1. Means A vector is not equal to B vector. लेकिन अगर हम इसका clearly यहाँ पर लिख सकते हैं हम clearly A vector is not equal to B vector because their corresponding components are not equal. अगर हम इसका magnitude अब निकालेंगे, now magnitude of A vector is equal to square root of 2 square plus J का है 1 square, square root of 4 plus 1, that is square root of 5. Mod B is equal to square root of 1 square plus 2 square. 1 plus 4, that is root 5. Modulus of A square root of 5, modulus of B square root of 5 means the two vectors are of same magnitude, but the two vectors are not equal, though they are of same magnitude. अब हम थोड़ा जान लेंगे multiplication of a vector by a scalar. Let A be any vector. Lambda be a scalar. Then the product अगर हम lambda से a को multiply करेंगे, then lambda a is called the by a scalar. Then the product lambda a is known as the scalar multiplication of a vector. Scalar multiplication of a vector. For example, अगर a वेक्टर है 2i plus 4j minus k, then say 2a वेक्टर 2 से मैंने a को मल्टीप्लाई किया, means scalar multiplication of a vector. That will be equal 2 2s are 4i plus 2 4s are 8j minus 2k. This is the scalar multiplication of a vector by a scalar. Now, certain things you have to remember, that the scalar multiplication of a vector is always a vector. That is 2 times a vector. It is also a vector. Means in general, lambda times a vector is always a vector. Number first. Number second, lambda a vector and scalar times a vector, they are collinear. Means they lie in the same line. Number third, lambda is always a vector. A vector and lambda times a vector are collinear, and lambda a vector is in the same or opposite direction of a vector. ये जो lambda a है, it will be in the same or opposite direction of a vector, depending on the sign of the lambda. Depending on the sign. अगर lambda positive होगा, तब lambda a vector will be in the same direction as of the a vector. If lambda is negative, then lambda a is in the opposite direction of the a vector. For example, यहाँ पे थोड़ा छोटी सी example है. This is a vector here. This is a vector. Say lambda के बदले हम लेंगे 1/2. It will be shorter, half of its length. It will be this. Direction same होगी, 1/2 of a vector. अगर मैं लूंगा 2a vector, थोड़ा बड़ा होगा, डायरेक्शन यही होगी, 2a vector. अच्छा, फिर हम अगर मैं लूंगा -2a vector, ये ऐसा होगा, 2a vector but minus, डायरेक्शन ये होगी, opposite. It is due for today.